thank you all for joining us. Tonight, our plan is to visit a series of deep sky objects, or DSOs, in the North Circumpolar Sky, principally in the vicinity of Ursa Major and its asterism, the Big Dipper, and its surrounding constellations. For your information, our moon is the largest in the solar system relative to its primary planet, and it is, I believe, the second largest moon in the entire solar system, after Ganymede of Jupiter, of third largest, and Titan of Saturn. It is a body that, by my current theory, was created when a Mars-sized protoplanet called Theia struck a glancing blow to the forming Earth in the early stages of the solar system. A good portion of the outer layering, which constituted the mantle of the Earth. And because when astronauts went to the moon and rock samples, they found it was very similar to basaltic rocks that constitute the oceans and the upper layers of the mantle. It is about 2,160 miles across, which makes it just about as wide as the United States. It is approximately 1/4 the diameter of the Earth, which is roughly 8,000 miles in diameter, and it's about 1/50 of the volume of the Earth, and it's about 1/80th of the mass of the Earth. Even though it is a fairly large body as satellites go, the moon is approximately 1/4 the diameter of the Earth, being 2,160 miles across. It is made of much lighter material than the Earth generally because, as I said, it consists of what is thought to be mantle rock that was knocked off the Earth by a protoplanet called Theia, about the size of Mars, back near the formation of the solar system some 4 billion years ago. And since Theia struck the Earth a glancing blow, it knocked off outer layers, which were the basaltic rocks, like ferromagnesian minerals, olivines, micas, things like that, which later accumulated from a ring of debris that was surrounding the combined Earth-Theia protoplanet, and then accumulated into two solid bodies. And theory has it that one of the solid bodies overtook the other one, and combined to form the moon as we see it in the sky now. And the reason why they think it consisted of two bodies is because the other side of the moon, the back side of the moon, is of a very different appearance and composition compared to the front side. So it's apparent that a very different second object smacked into the back of the moon, which now, being lighter, continually faces away from the Earth. The moon, as you know, is gravitationally locked to the Earth, which simply means that the heavier side of the moon is always facing bottom, which means down toward the gravitational center of the Earth, namely the center of the Earth. Because the moon is considerably lighter than the Earth, about 1/50th of the mass of the Earth, the barycenter, Barycenter, or the gravitational center of the Earth-Moon system, is actually located within the body of the Earth, about 1,000 miles deep, if I recall. The moon is only about 1/80th the mass of the Earth. As you look at the moon, the side facing us, you see that there are dark patches, generally round in many cases, and those are called the maria of the moon. Maria is from the Latin word for seas, S-E-A-S, but there is no water there. Those are actually lava flows, dried lava flows from the era when the moon was actively volcanic on the inside as a result of the heat generated by the impact which formed it. And now that it has cooled, it has frozen, if you want to call it solid rock frozen, all the way to the center, and there is no more volcanic activity. So there are no more outflows of lava. But the large lava flows that we see on the Earth-facing side of the moon, the largest of them is called Oceanus Procellarum, the ocean of storms. The Sea of Tranquility, Mare Tranquillitatis, where the Apollo 11 first landed back on, I believe it was July 20th, 1969, is another. Right alongside it is Mare Serenitatis, the Sea of Serenity, and Mare Crisium, the Sea of Crises, is a small circular one right on the edge. There are a number of other seas. Those are the most prominent ones and the ones most often spoken of. There is a theory that there's another moon-like object in orbit about the Earth, but I don't think anyone has proven it definitively. I might mention that we're actually very lucky to have the moon. In all likelihood, its inertia and its angular stabilization of angular momentum of the Earth has caused the Earth's libration or nodding to be minimized, causing the temperature regimes on the Earth to stabilize to a much greater degree than if we didn't have that enormous moon. And the result is that it had a lot to do with stabilizing the climate regime on the Earth, which enabled life to develop more rapidly. Its tremendous gravitational pull caused a great deal of tidal activity at the edges of the oceans, which probably had a lot to do with advancing the development of life from simpler forms to more complex forms. And it also provides a source of light in the night sky, which also may have had to do with the development of photoreceptors for life forms which live and function primarily at night. Are there any questions or contributions from the listeners with regard to the moon? I apologize for being kind of halting. I didn't actually prepare a script for this. I wasn't expecting to address it tonight, but I hope that you found what I said interesting. Okay. Well, in that case, I'm prepared to move on. What do you think, Ed? M5 or M13?
M13 is almost straight up.
M11. Okay.
Or which one do you want?
My script says M5, then M13, and then, let's see, let me find M11.
Okay, we can go to M5.
M11 is about object 6, I think. Okay. So let's go for M5. Messier number 5 is a globular cluster in the constellation Serpens, the snake. It was discovered by Gottfried Kirsch in 1702. M5 is, under extremely good conditions, just visible to the naked eye as a faint star-like object. Binoculars or small telescopes will identify this object as non-stellar, while larger telescopes will show some individual stars, of which the brightest are of apparent magnitude 12.2. M5 was discovered by German astronomer Gottfried Kirsch in 1702. I got a duplication there, when he was observing a comet. Charles Messier also noted it in 1764, but thought it was a nebula without any stars associated with it. William Herschel, the German-born English astronomer, was the first to resolve individual stars in the cluster in 1791, counting roughly 200. He had the advantage of having the largest telescope around at the time, except for Lord Rosse. It was 40 inches across the mirror, and it was a Newtonian-style telescope, used mirror, and it was about 40 feet long, and it was mounted in a huge wooden structure that was operated by several men. And doing that, he created actually the new general catalog. He and his sister, who rarely gets credit for it, new general catalog of deep sky objects called NGC objects. And he also discovered the planet Uranus, the last one to be discovered by direct observation by an astronomer. The interesting thing about his telescopes were that they did not use glass mirrors. They used something called speculum metal, a combination of three metals, which I used to know, and they were very bright and reflective, but on the other hand, they tended to tarnish rather quickly. So the common practice among astronomers who could afford it was to have two mirrors, one of which was always being repolished with optical rouge. And believe me, that's a slow process, optical rouge. And while the other one was in the telescope and being used functionally.
Okay, there's M5.
Okay, yes, oh, very nice image. Hard to believe that they couldn't see individual stars in that at some point. And Hanan is mentioning, very nice. Thank you. I'll take personal credit. Okay, the image is brightening up, because a function of the EV scope, which Ed is using for this display of objects, is that it does photometric stacking as it remains focused on the object, and so the image brightens up and gets clearer and more expressive, if you want to call it that, as you continue to watch. So the longer you watch, the brighter the image gets, and that certainly is working here. Okay.
And again, if anybody has any questions or something, you can ask them in the chat, and certainly if somebody has a big question they want to know, we can unmute you and let you ask it directly.
I saw Steve just posted a chat message with regard to the center, but I didn't quite catch what it was about. Something about gases, but I didn't catch the.
So Steve's question is, Steve was, so is the bright center made of looks like star gases?
Made of what kind of gases? Oh, stars or gases?
Yeah.
Well, principally it would be stars. The characteristic of mature galaxies is that there's a heavy concentration of stars toward the center, but most of the gases, which are the star-forming regions, are out in the spiral arms, not in the center. If I remember descriptions of galaxies, it was said that the centers of galaxies, as with globular clusters, consisted of population 2 stars. They tended to be relatively smaller, yellower, dimmer, consisting principally of hydrogen and helium without too much in the way of heavy elements, and that the centers of galaxies predominated with those kinds of stars, whereas the bright whitish and bluish young stars that contained the resultant elements from supernovas and second and third generation star formation tended to be in the spiral arms, out where the so-called open clusters or galactic clusters are located. That's where most of the gas is. Now, obviously, there are bound to be exceptions, but that's what I understand was the general rule with regard to spiral galaxies. Okay, Ed, your next object. Okay, Comet Neowise. C/2020 F3 Neowise is a long period comet with a near parabolic orbit discovered on March 27th by astronomers using the WISE, or Wide Field Red Survey Explorer space telescope. At that time, it was an 18th magnitude object located 2 astronomical units, about 190 million miles, away from the sun, and 1.7 astronomical units, or AUs, that's 160 million miles away from the Earth. 2 from the sun, 1.7 AUs from the Earth. By July 2020, it was bright enough to be visible to the eye. It is one of the brightest comets in the northern hemisphere since Comet Hale in 1997. Under dark skies, it can be clearly seen with the naked eye and remains visible throughout most of July. As of July 23rd, the comet was about 2-3, but binoculars are required near areas. For northern hemispheric observers, the comet can be seen on the northwestern horizon with the Big Dipper. On July 17th, it entered the the constellation of Ursa Major below the Big Dipper. The comet's systematic designation of C/2020 F3 indicates a non-periodic comet and the third discovered in 2020. Comet Neowise made its closest approach to the sun, its perihelion, on July 3rd at a distance of 0.29 astronomical units, or about 27 million miles. This passage increased the comet's orbital period from about 4,400 years to about 6,700 years. So it's going to be in a larger orbit now, taking much longer to come back. Its closest approach to Earth occurred on July 23rd at a distance of 0.69 astronomical units, about 64 million miles, while in Ursa Major. In early July, the comet could be seen in the morning sky above the northeastern horizon and below Capella. Seen from Earth, the comet was less than 20 degrees. The comet could be seen in the morning sky above the northeastern horizon and Capella. Seen from Earth, the comet was less than 20 degrees from the sun between June 11th and July 9th. By June 10th, the comet was being lost in the glare of the sun. It was apparent magnitude 7. Okay. In early July, the comet could be seen in the morning sky above the northeastern horizon and below Capella. Seen from Earth, the comet was less than 20 degrees from the sun between June 11th and July 9th. By June 10th, as the comet was being lost in the glare of the sun, it was apparent magnitude 7. It brightened to about magnitude 3 when it reached 0.4 astronomical units, or 33.37 million miles from the sun, and 1.4 astronomical units, or about 130 million miles from the Earth. At that was magnitude 3. By early July, Comet Neowise had brightened to magnitude 1, far exceeding the brightness attained by previous comets, including C2020 F8 Swan and C2019 Y4 Atlas. It had also developed a second tail. The first tail is blue and made of gas and ions, with a red separation in the tail caused by high amounts of sodium. The second twin tail is a golden color and made of dust, like the tail of Comet Neowise. This combination resembles Comet C2011 L4 pan-stars. The comet is brighter than C2011 L4, but not as bright as Hale-Bopp was in 1997. According to the British Astronomical Association, the comet brightened from a magnitude of about 8 at the beginning of June to -2 in early July. That would make it brighter than Hale-Bopp. Its nucleus actively subsided after mid-July, and its green coma became clearly visible after that. On July 13, 2020, a sodium tail was formed by the Planetary Science Institute Input-Output Facility. Sodium tails have only been observed in very bright comets such as Hale-Bopp and Comet 2012 S1 ISO. Neowise's retrograde orbit crossed the plane of the ecliptic, to which it is inclined by about 129 degrees, and did so in late June. On July 18th, the comet peaked at a northern declination of 48 degrees. From the signature, the diameter of the comet nucleus is estimated to be approximately 3 miles across. The nucleus is similar in size to Comet Akutake in 1906, and many short periods. A number of authors have suggested that the comet could become a so-called great comet. However, this distinction is usually reserved for easily observable in the naked eye, even with low to moderate light pollution. Examples over the decades have included Comet Ikea Seiki, the brightest comet of the 20th century, Comet Pitt in 1970, Comet West in 1976, and Hale-Bopp in 1996 and 97. We're still waiting for the greatest comet of the 21st century. Okay, any questions with regard to Comet Neowise?
We just had a few people saying good image, and I think Bill was wondering if it was possible to zoom out a little bit more, but I guess probably not.
That's far out. Yeah.
The telescope is pretty much fixed field. Doesn't really
Yeah, I can
lend
zoom.
itself to that.
Yeah, it's about a half degree. So,
Half-degree field, that's about the diameter of the moon as seen in the sky.
That was the only questions we have so far. If anybody else has any, feel free to bring them up in the chat. If you got something really, a big long question, feel free to just let us know. We'll get you unmuted. You can ask it.
M57 is known as the Ray Nebula, one of the most well-known and beautiful objects of the deep sky, despite its small size. It's located in the constellation of Lyra, the Lyre. That's L-Y-R-E, not L-I-A-R. A type of harp played by a sun god Apollo in Greek mythology. Actually, in Roman mythology, Helios, Greek mythology. It was discovered by French astronomer Charles Messier while searching for Comet Bode in late January 1779. Fellow French astronomer Antoine Darquier de Pellepoix, how do you like that accent? Later reported that it was as large as Jupiter and resembled a planet. which may have inspired the type name Planetary Nebula by which it's known. It would be entered into the catalog as the 57th object. Both Messier and German-born English astronomer William Herschel incorrectly speculated that the nebula consisted of multiple faint stars, which were simply unresolvable with their telescopes. In 1800, German Count Friedrich von Hahn announced that he had discovered the faint central star at the heart of this nebula a few years earlier. However, he noted that the interior of the ring had undergone changes and said that he could no longer find the central star. That's very interesting because it indicates rapid change within the planetary nebula, with expanding gases and changing the shape of the shell of gas surrounding the white dwarf. In 1864, English amateur astronomer William Huggins examined the spectra of multiple nebulae. He discovered that some of these objects, including M57, displayed the spectra of bright emission lines characteristic of fluorescing glowing gases. Huggins concluded that most planetary nebulae were not composed of unresolved stars, but were in fact nebulosities, or clouds from the Latin. These nebulae were first photographed by the Hungarian astronomer Eugen von Gotthard in 1886. Messier 57 is located south of the star Vega, which forms the northwestern vertex of the Summer Triangle. It's a hot blue double star with newly forming planetary systems and is the brightest star in spring and summer skies. The nebula lies about 40% of the distance from Beta to Gamma Lyrae, making it an easy target for amateur astronomers. The nebular disk has an angular size of 1.5 arc minutes, making it too small to resolve in 10 by 50 binoculars, like the one in front of me. It's best in at least an 8-inch telescope, but even a 3-inch will reveal its elliptical ring shape. The interior hole can be resolved by a 4-inch instrument at a magnification of 100 power. Larger instruments will show a few darker zones on the eastern and western edges of the ring and some faint nebulosity inside the disk. The central star at magnitude 14.8 is difficult to spot. And I haven't actually looked at the image yet, but my recollection is that there's a distinct coloration, particularly pinkish or reddish, toward the periphery on the left side. Are we seeing that?
Yeah, you can tell. You can tell it's got a reddish pink outside, goes into a white and then to a blue.
That's an impressive feature because it's rare to see color in the sky with the eye through a telescope. Ah, yes, that's a very nice image. I see it now. I expanded it. The nice thing when you're viewing it on a phone, you can spread your fingers to make the image bigger, as if putting it under more magnification, and it looks beautiful. The nebulosity in the middle, visible in the hole, is representative of the fact that it is not really a ring of gas. It's a shell, kind of a cylindrical shell or spherical shell. And the reason that we are looking through it and seeing it as a ring is because the density of the gases on the side tend to be more obscuring than those in the center, where we're looking through the front layer of gas.
If anybody has any questions or anything, feel free to break them into chat.
What about M27, Ed?
Okay.
Messier 27, the Dumbbell Nebula, is also known as the Apple Core Nebula. It's a planetary nebula in the constellation Vulpecula, the Little Fox, located hard by Cygnus the Swan, about 1,227 light years away. This object was the first planetary nebula to be discovered by Charles Messier in 1764. At visual magnitude 7.5 and with a diameter of about 8 arc minutes, it's easily visible in binoculars and a popular observing target in amateur telescopes. The Dumbbell Nebula appears to be shaped like a prolate spheroid, kind of like a football. It is viewed from our perspective along the plane of its equator. In 1992, its rate of expansion in the plane of the sky was measured at around 2.3 arc seconds per century, suggesting an age of some 14,600 years. In 1970, Bohosky and Wiedemann found an expansion velocity of 31 kilometers per second with a semi-minor axis radius of 1.01 light years. This implies that the kinetic age of the nebula is some 9,800 years. So it's a difference of opinion. 14,600 versus 9,800. But the significant point is that it's not millions of years old, like galaxies and globular clusters and things like that. It's actually just a few tens of thousands. Like many nearby planetary nebulae, the Dumbbell contains knots, K-N-O-T-S. Its region is marked by a pattern of dark and bright knots. The knots vary in appearance from symmetric objects with dark tails to irregular tailless objects, as with the Helix Nebula and the Nebula. The heads of the knots have bright cusps, which are local ionization fronts. The star, a white dwarf progenitor, is estimated to have a radius of 0.055 solar radii, which subtends 0.13 light seconds, a size larger than most known white dwarfs. The central star mass was estimated in 1999 to be 0.56 solar masses, or somewhat more than half the mass of our sun, which is considerable for a white dwarf, which in some cases will have blown off 90% of the mass of evolution. Was one of those fellows who kept his head above while others were losing theirs, just before the French Revolution. And astronomers back then were considered, they were patronized by the royals, by the upper classes, and so they were considered part of the upper class, and therefore not exactly popular at the time of the French Revolution. He kept his wits about him and he kept his head. How would you feel about NGC 4565, the Needle Galaxy?
And again, if anybody has any questions or comments they want to relay over to Mike or whatever, you can use chat, and Mike can answer your questions. We do seem to be having a little bit more audio troubles this time than last time, but I think we can still get your questions answered if you have any.
I'm happy to try. Okay, are we ready, Ed?
Yeah, we were on the galaxy.
Okay. So NGC 4565, an object cataloged in William Herschel's New General Catalog, hence NGC, is also known as the Needle Galaxy. It's an edge-on spiral galaxy about 30 to 50 million light years away in the constellation Comet Berenices, Berenices Hare, or the Northern Crown. It lies close to the North Galactic Pole and has a visual magnitude of 10. It's called the Needle Galaxy for its narrow profile, first recorded in 1785 by Herschel with his 40-inch, 40-foot-long Newtonian reflecting telescope. It is a prominent example of an edge-on spiral galaxy. Herschel's sister, by the way, got little of the recognition, but was a capable observer and reader in her own right. Herschel's son, John, would later assemble the first great catalog of pictures of the southern sky from Cape Town in South Africa. NGC 4565 is a giant spiral galaxy, more luminous than M31, the Andromeda Galaxy, which is the largest member of our local group of galaxies, and the closest big spiral at 2.25 million light years distance from us. Much speculation exists in literature as to the nature of the central bulge in 4565. However, its exponential shape suggested that it is a barred spiral galaxy. Space telescope have confirmed the presence of a central bar, but also show an inner ring. Like M31 and our own Milky Way, NGC 465 has two satellite galaxies, one of which is interacting with it. It has a population of about 240 Globular clusters, more than the 140 in our own galaxy. So Messier 39 is an open cluster of stars in the constellation Cygnus, the Swan, also known as the Northern Cross. Around 9 degrees east-northeast of Deneb, a star some 50,000 times the luminosity of our sun and more than 1,500 light years distance, the farthest individual star visible to the unaided eye. A huge white supergiant General feels that the big stars live fast and die young. Its lifespan will likely be less than 1/10 that of our sun. The cluster was discovered by Guillaume Le Gentil in 1749. Charles Messier added it to his catalog in 1764. When observed in a small telescope at low power, the cluster showed around 24 stars, but it is best observed with binoculars. It has a total brightness of magnitude 5.5 and spans an angular diameter of 29 arc minutes, about the size of the full moon. M39 is about 1,010 light years, also 311 parsecs, from our sun. The cluster has an estimated mass of 232 solar masses and a linear tidal radius of 8.6 parsecs, which is about 25 light years. Of the 15 brightest components, 6 form binary star systems. Another is a probable eclipsing binary system with a period of 113.2 days. There are at least 5 chemically peculiar stars in the cluster and 10 suspended short period variable stars. Quite unique. Okay. How are we on NGC 40? Can we get to the Bowtie Nebula?
Yeah, we can get there. I hope so. I mean,
Okay, let's give it a try. Okay, so NGC 40, also known as the Bowtie Nebula, is a planetary nebula in the constellation of Cepheus, or Cepheus, the wimpy, hen-pecked king of Greek mythology. Discovered by William Herschel on November 25th, 1788. It's composed of hot gas around a dying star that has ejected its outer layer to leave behind a smaller hot star with a surface temperature of 50,000 degrees Celsius, almost 10 times that of our sun. It's about 1 light year across. About 30,000 years from now, scientists theorize that NGC 40 will fade away, leaving only a white dwarf star approximately the size of Earth. It formed when a shell of ionized gas is blown into the surrounding interstellar medium by a star in the last stages of its evolution to become a white dwarf.
Hey, Mike, Ken's looking to see if you guys might be interested in showing M71 or NGC 40.
We do have NGC 40. That's the one we just discussed, the Bowtie Nebula.
Yeah, I guess I think he just showed up.
Okay. And
it's on there now.
M71, we don't have a script for that. We could look for it.
Yeah, it looks like Ken's got some good points. I'm trying to open it up to him to tell, but he says M71 was discovered by Philip, a good French name I won't be able to hit, in 1745, and it's about 12,000 light.
12,000 light years away.
Yeah, that's what he said.
Okay, so that would make it a globular or open cluster within our own galaxy. Looks sort of like an open cluster, rather tight. I would estimate between 50 and 120,000 stars. Anything else to add on M71?
Let's see, Ken says that it's relatively young, only 9 to 10 billion years old.
All right. Well, it's a lot quieter here now than it has been for a while. We appeared to between car engines and chattering kids and sprinklers and the like. We had quite a bit of competition for sound.
Yeah, I was there last weekend, and there were a lot of people there. Yeah, quite full.
Well, it's idyllically quiet and dark now. Beautiful night. So M51, the Whirlpool Galaxy, is now on the screen and enhancing. So this object is also known as NGC 5194. It's an interacting grand design spiral galaxy that lies in the constellation Canis Venatici, the 2 hunting dogs. It was the first galaxy to be classified as spiral. Its distance is estimated to be 23 million light years away from Earth. The galaxy and its companion in a regular galaxy at the end of one spiral arm, called NGC 5195, are easily observed by amateurs and the two galaxies may be seen with binoculars. The Whirlpool Galaxy has been extensively observed by professional astronomers who study it to understand galactic structure, particularly that associated with spiral arms, as well as galaxy interactions. What later became known as the Whirlpool Galaxy was discovered on October 13, 1773 by Charles Messier while hunting for objects that could confuse comet hunters, and was designated as Messier's catalog M51. Its companion galaxy, NGC 5195, was discovered in 1781 by Pierre Michon, although it was not known whether it was interacting or merely another passing galaxy. In other words, it appears to be connected at the end of the spiral arm of M51, but it's unclear whether it is physically at the same distance or in front of or behind M51. In 1845, William Parsons, the third Earl of Rosse, or Lord Rosse, employed his transit-oriented 72-inch, 1.8-meter reflecting telescope in Birr Castle in Ireland, an observing location with frequent lousy weather. He found that the Whirlpool possessed a spiral structure, the first nebula known to have one. These spiral nebulae were not recognized as galaxies until Edwin Hubble found Cepheid variable stars in some of them. Since the brightness fluctuations of variable stars grows longer with the size and therefore brightness of the star, it's possible to use them as standard candles or standard headlights to estimate distances. So therefore, these stars, Cepheid variables, and therefore their spiral nebulas, were so far away that they were revealed to be entirely separate galaxies outside our own. That was the great discovery and contribution of Edwin Hubble. The advent of radio astronomy and subsequent radio images of M51 showed that the Whirlpool and its irregular companion galaxy are indeed interacting. Sometimes both together are called M51, in which case the individual galaxies may be referred to as M51A and M51B. Okay, that concludes.
Okay.
Does anybody have any questions? We can open it up. Let's see. Ken also recommended maybe the Cat's Eye Nebula.
Yeah, that's
He wasn't sure if that one would be available. And NGC 6543.
Problem is, it's cat's eye, but there's no cat's paw.
yeah.
My imagination, or is it getting a little hazy up there?
It's getting much easier.
Okay, so it actually has about 4 different names,
Yeah, I
if I
know.
recall. I always like to call it the Zorro Nebula.
Well, I can see why.
The Swan Nebula, I think, is the other common name for it. And it is one of the largest, most prolific star-forming regions in our galaxy. I don't have it right in front of me. It is an exceptionally beautiful object, and it's getting down right into the star clouds of the center of the galaxy.
Yeah.
In the constellation of Sagittarius. So Ken was, I don't know if you want to try the cat's eye. That was
No, I
NGC
get it.
6543, I think.
That side's a little boring, but
Certainly not like this one.
no. Okay. There it is for what it's worth.
That's the cat's eye. Huh?
Yeah. I just expand this so you can see it.
Of
Alrighty, are we gonna knock it down?
Yeah, I think we'll call it a night. Let me give my sign off here. Just a moment.
Yeah.
All right, folks, I think that's the show. And we'll try again another night, see what else we can see.